All right, so continuing our whirlwind tour of numbers and variables, we're going to talk about very, very large and very, very small numbers today. So, in our world that we live in, there are many situations where numbers are either way too big or way too small to represent using our standard representations. The example I'm going to give here is Jeff Bezos. If you don't know, Jeff Bezos is the CEO of Amazon. He's also the founder. He started it in a garage in Palo Alto, California in the early 1990s. And now he's worth $110 billion. As a number, $110 billion looks like that. It is ridiculous to write that out. There are so many zeros and it's so big. So we've come up with a way that we can shorten things when we have a specifically very large number. So the number is so big it's essentially meaningless, and it's very difficult to write that down. It's easy to lose zeros. It's easy to not keep track of where your commas are. So we often come up with a new way of writing it, and that way of writing it is called scientific notation. Scientific notation was created specifically for numbers like this, like how much money Jeff Bezos has, how many atoms there are in a human body, how many goldfish there are in the world, how many grains of sand on a beach. Any number that you'd like to think about that's very, very large can be represented using scientific notation. Essentially, what scientific notation does is to have one number in front of a decimal point. So in this case, that would be that leading one in the $110 billion. And then only two numbers after the decimal point, and the rest of it is represented as a power of 10. So for example here, for Jeff Bezos, it would be 1.1 times 10 to the 11th. Now the way that you can get to that 11 is if you imagine you've got a decimal point here. We're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to get it so that it's behind the first number. And so that would be 1.1 times 10 to the 11th, because I had to move the decimal point 11 places to the left. It also means that if I want to change this from scientific notation into our standard notation, I'd have to take the decimal point and move it 11 places to the right to get to the full number. So to turn this into a normal number, you need to move the decimal point 11 places to the right. That's the significance of the 11 here, this 10 to the 11th. Now, scientific notation can be used for very, very small numbers as well. So an example of a very, very small number is a single molecule of caffeine. I know you guys think about caffeine a lot, but how much have you ever thought about exactly how big a single molecule of caffeine is? A single molecule of caffeine is 0. A whole bunch of zeros, I'm not even going to say them all, 61 meters wide. Now, this number is, again, it's so small that it's essentially meaningless. So in order for us to actually wrap our minds around it and be able to write it in a relatively compact form, we can write it in scientific notation. Now, because we're going to be moving the decimal point to the right here to get it behind that first number, so you always want to make sure you have one number in front of the decimal point. Since we're moving to the right, it's going to be times 10 to a negative number. So in this case, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 6.1 times 10 to the negative 10th, where this negative 10 means that I move the decimal point 6 places, or it's not 6, 10 places to the right. To rewrite it in standard form, I'm going to move it from where it is right now, 10 places to the left. Okay, so there we go. Very large, very small numbers. The assignment for this one is going to be on Delta Math. I'm going to go through you guys as a class how to log on to Delta Math and how to do the assignment and how to get help from Delta Math if you need it. So we'll talk about that as a class when we get closer to this assignment. Hope you enjoyed. Have a great day.